Hey guys, this is our Copy Jam Detector. Today we are going to be testing it. This is using the PLD board, which is a programmable logic board, which also has a breadboard on it. This is the setup we have on it. This is a circuit which in a copier would actually be able to detect whether or not it has a jam or not. For what we're using it right now, this isn't actually implemented into a copier, so it's not going to do the same exact thing, but this is a sort of replica of it. The way it kind of works, which we've just kind of recently tested, which we've only done it a few times, it works in a way where if one of these has been tripped, it's not going to do anything. But if two of them are tripped, it will show off a buzzer, which will tell you that it has a jam within the system. So therefore, when a piece of paper is ran through, it'll blink a little bit, but it won't actually sit and jam. But let's say your piece of paper was going through and actually had jammed, it would hit both of them and would stay on for a certain period of time. So therefore, the way that it's set up is the buzzer, which is hooked up to a GPIO pin, has the ability to tell you, okay, this is when a jam has been detected. Which we have two circuits here, it's not just one circuit. We have one for the actual light sensors and one for the lights themselves, which are little LEDs. They're 9 volts. They're ran off a power supply. If you can look at it real quick, I'll show you the voltage. That is ran through another breadboard, which we separated. So it makes it to where the positive negative is bused into another positive negative that leads off into a series circuit here. Now, we have also the multi-sim of the Copy Jam Detector, which makes it to where within this, if it is hooked up to a USB, you can actually transfer the file over from the computer onto the board itself, which makes it able to do whatever program you have ran. Now, this one is a little bit different than some circuits that have been used. Programmable logic allows you to not have any wires at all, but we have actually used some wiring, some resistors, and also the power supply, which is hooked up to the LEDs. So we actually, because of the fact that we had more hardware than more of a software thing, because of the fact that instead of just having, like, let's say using a 7-segment display or maybe using an LED, we're actually using a hardware item which needs the wiring for it. For this type of circuit, it also, because of the fact that we want to know visually, not just with sound, we have also hooked up an LED to the back. If you want to zoom in on that. So what happens is when this is actually tripped, there is an LED that will come on in the back, if you can see that. That is outputted right here. This wire will output from the GPIO pin that is connected to the buzzer, will output to an LED port, which is connected back here to an LED. I think that's about it.